So I'll be continuing from the last stage. So I substituted f as 100 and then x as 0.3, s as 40 and y as 0. That is equal, because it is a pure solid, that is equal to m, which I got as m is equal to 140 and xm1. So by solving this equation I will get xm1 equal to 0.214. Okay, so now what we'll be doing is we'll be plotting the graph. So this is the equivalent data which has been given. This is a water layer, that is a raffinate. This both curves raffinate and this both curves representing the extract. This is weight fraction of acetic acid, weight fraction of water, weight fraction of acetic acid, weight fraction of water. Now as you can know, the question arises that which one we should take as x and which one we should take as y. Okay, so first we'll be finding, we have to plot this curve. Okay, now in order to plot this graph, what we'll be doing is, first of all, just keep an eyes on this numbers. If you see this number as 0.993, definitely weight fraction of water will be on x-axis, because x will be varies from 0 to 1. So this will be definitely water. So water 0.993. So this is our x, and this will also be x. So first, and this will be y. If it is x, definitely this is y. So we will be plotting the graph y versus x. If you plot this y versus x, you'll get this curve. Again, for the x, if you draw y as this and x as this, you will be getting this curve. Okay, this curve. So now after having this, you will be having this curve. Okay, now for this curve, what you will take is, we all know that in the diagram itself, you might have seen that the concentration is y1 and this is x1. Means for raffinate it is x1 and for extract it is y1, right? So for y1 it is given as, so definitely extract will be always in the y1, right? So we'll consider only solute, that is acetic acid and acetic acid. Now in this we have to take one as y, one as x. This is extract means y, we'll take as y. So and this as x. So we'll plot y means y will take as this number as y and this number as x, because it is an extract. Weight fraction of acetic acid in extract, because acetic acid in solute and this acidic solute in raffinate. So we'll plot the graph and we'll get this curve like this. Now see, we got xf as 0.3, right? In the last question here we got as xf as 0.3 here, xf 0.3. So in this graph, as you can see from here, which is a 0.3, right? This is our point xf. Okay, and pure solvent, right? So ys is 0 initially, it means from here. Now we'll draw this line, we'll connect this line from 0.3 to 0, and we got from here xm as 0.214, right? So what we'll do is, we will take 0.214 here, 0.214 here, and we'll extend this line to point this. Now this point will be our xm1, means m, that is what this is, point m. So now we have to get, if you see the rough and tough diagram, will draw like this. The curve will be like this and this curve will be like this. Okay, now if you take any point from here, this will be up to this, means, and this, if you extend this will be up to this, and this is our tie line. So it is E, this is R, right? Now to this is a tie line, right? A tie line connects E and R. Now to draw this line, we have to first assume any point on this, any point on this, and then we have to project this line to here. Okay, this will be our point E. Again we have to take this point here, we need to drop here, and we have to extend this up to here, and then we need to join the point. So here, suppose if I take any point here, okay, what I'll do is I will extend this line up to curve here out, because this curve will go to up to extract. As you can see, this curve is going up to only extract. This diagonal line will go to the raffinate. So here is, suppose if you take this point as this curve will go only up to this, and if you extend straight this equilibrium line will go to the raffinate. And then if you suppose this is our point R and this is our point E, right? This is R, this is E. If we join this point, this line, if you join this point, this line has to cross this XM, but here this is not crossing. So whatever the point you have assumed, it is wrong. So you have to change the another point. Suppose if I take this point as here, then what I'll do is I will project this point up to here, I will extend this point up to here, then I project this point up to here, then again this is my R, this is my E, I will join this 4 point. If again I am not intersecting, so whatever the point I have assumed is wrong. So in this way I have to change each and every point, and then the moment I get the line like this which intersect the point, that will be my R. Okay, that will be my R and that will be my E. So R, whatever you will get, you just see from here. Suppose if you're getting R as here, the extend this, you will be getting as at 0.35. So R1 will be your 0.35. Once you get this R1 0.35, this will be your feed, because I said you that R1, whatever the R1 we are getting, this will be our feed to the fund. So similarly we will be proceeding in the similar way. Once you get this R1, again we will join this R1 to 0, because ys is 0. In the second stage also ys is 0, right? So I will join this R again to this here. Again I will assume some point, I will see from here, I will extend this. If I intersect this, that will be my R2. Suppose I get this R2 as here, then again I will intersect this. So in this way I will see the three process, and then I will, whatever R3 I am getting, that will be my final answer, suppose 0.27, and whatever the E1 I am getting, that will be my E1 plus E2 plus E3, that will be my desired answer. Thank you.